Sorry for the technical difficulties. It's a quite strange situation when we half online and find half meeting the conference. I'm the head of the data center here, so in a few slides, data center and also or cloud services, and what kind of hardware and software makes possible to use these resources. And in the second part of the presentation, my colleague György Mező will talk about actually EPU, GPU usage in some case studies, how actually physicists and other scientists use our resources here in their research. So the Wigner Data Center belongs to the Wigner Research Center for Physics, and we have scientists and other organizations too. First is the data center service and then infrastructural service. And we have an ongoing project in which we try to extend and give in the future platform service as well. Till the last year, we hosted the LHC Tier 1 data center for CERN. We then moved back to Geneva and CERN itself. What actually data center service means? Of course, it is faced with a fully equipped environment, including PDU and backup UPSs, huge aggregators. We have two independent power lines to the Hungarian power grid, just to make sure that the power is flowing every time, full day and time. Cooling, just a simple word, but actually it means a lot of equipment too. Devices, piping, monitoring, fire alarm system, and also fire extinguisher, just to make sure nothing happens, nothing bad happens with the devices. Of course, the environment is monitored, which including not only the temperature, but the pressure, voltage, liquid dropping, even closing and opening the doors. The operational staff is here 7 days a week and 24 hours a day in daytime, and at night it means duty. And the whole area has a strong physical security, so which means cards, physical cards and pins, so the two-factor authentication, which give access even to the staff to the areas which are needed for them to perform their job. And it's only that. What our data center as a services customers, first is governmental organizations, they have their roots, also research groups like ELKH, and the ELKH cloud itself also as a DCS customer. The infrastructure service at the moment means actually the ELKH cloud, which started at 2016 as a scientific research cloud service and was funded by the Hungarian Academy of Sciences. This cloud service aims to give access to resources to any Hungarian research institute members, so anyone can come up with a project, submit it, and then a small active committee decides whether we can give access to resources and whether the two physical places, which one will serve best this given project. So we have two physical size places for this cloud. One is for the Institute for Computer Science and Control, Staki, and the second one here at the data center. The hardware currently we have combined at Staki and Wigner is more than 1,000 virtual CPUs, more than 3 terabyte memory, almost half terabyte storage, and 12 GPU cards. In the data center, we have a tape library as well, and we are working on to extend the cloud software and possibilities just for any cloud project to use this tape library as a long time archiving possibility. Our network was completely reworked last year. It's Pioneer technology. It is capable of 100 gigabit per second bandwidth. At the moment, we use 10 gigabit, and our project aims to use this capability fully and to give 100 gigabit per second connection between every nodes and storage in the network. We use Ceph as a file system, OpenStack as a cloud software, and OpenVPN gives access to the scientists the given resource they were given in our cloud software. So that's it, and the next part will be actually GPUs and the case studies by György Mező. Thank you.
So first, I show you the existing GPU infrastructure in the ELKH cloud. And next, I selected some projects that we made together, research institute, universities, and industrial company. And I show you the results and many videos of this project. But I analyzed this project from the data center perspective, the service perspective, and at the end, I show you the planned expansion of the ELKH cloud infrastructure. The ELKH cloud has two sides and two branches. One is the big data center, the other the Institute for Computer Science and Control. This makes the possibility to make two strategies. For example, the GPU computation. The big data center choose to one server with 4 GPU cards. The other side choose the 3 server and also 4 GPU cards. In the big data center, it is possible to experiment how to connect together with the help of the NVIDIA link this 4 card, and the other side, other hand, seamlessly integrated the GPU servers in the OpenStack cloud, so the user can use just try to connect the OpenStack cloud. But in the linear data center, the service, the user, and project-based. We every project needs and try to make the best available techniques to solve the problems. Okay, I talk about this project. You see, there are projects from research institute, namely, for example, the Institute of Experimental Medicine, the Konkoly Observatory, universities, the ELKH University, and also the Technical University of Budapest, and the company who is the distributor, the ANSYS program, the Econ Engineering Ltd. Okay, first, one project from the Konkoly Observatory. The user or the project director was expert to write C and C++ code for GPU cards. Also, Zsolt Regali has astrophysical that heavily use GPU cards. But you can imagine when one student arrived in the laboratory and starting new tools. And so to install every time new tools, it is difficult, much more simple to use the Docker technology. But with the Docker, there is many problems, security problems, and also in that case, how to remotely render the simulation. So in this project, we solved some of these problems, and the result was that the company GPU laboratory is using Docker technology on every server. The company observatory has also a 3D projector system. We made animation for the Mars surface, and it was an interesting experience to see that the Blender able to use every NVIDIA card together, and other thing that the CPU is also used heavily. So when someone builds a GPU server, it has to decide the balance, the equilibrium between the CPU capability and the GPU capability. Okay, at the company observatory, starting and machine learning groups. In this day, many research centers interested in machine learning is a fashion today, and also very useful tools for data discoveries. So there are many groups that start using these techniques, and in that case, it is best to pre-install programs for these groups and help use these groups, these techniques. For example, my experience is that Jupyter Hub is very useful to service many users, and much more advanced user can use also the OpenShift that cover all the development phase for a project. There was also expert user with the, from the Western University. They build a system that can able to decide that some patient tissue is have cancer or not. In that case, it was interesting that that when starting the project, the resource is not so high, but if we try to better allocate the resources, it is important to make, for example, burst infrastructure with orchestrating, with the help of orchestrating. So the Mező expert user can use the resources. Time, the expert user sometimes use all the available resources. And other type of users of the clouds, for example, in the field of life sciences, has sometimes concrete programs. In that case, the support just to install and make comfortable the data upload and download, and to plan the resource uses. Okay, some engineering project. It was interesting to see the idea in the case of the new bridge of Cameroon, that the technical university tried to build a digital twin model. This means that the model mirrored the physical reality, and they planned the operation of the bridge based on the calculation of this digital model. So we installed the ANSYS program, and the GPU start to build up the building blocks of this big model. But in reality, this project needs, I think, a separate, dedicated infrastructure to make, to reach the aim of this project. After we connected with the distributor of ANSYS and made benchmarks. We benchmarking the ANSYS, how to scale up the different finite element analysis programs with the help of the GPU, and also benchmarking the cloud on servers and make comparison with the other high-performance computing cloud. There are many types of clouds, and it is a good question. For example, which cloud is the best for the user? At the end, the planned expansion of GPU capacities and services. In the bigger data center, we plan to purchase GPU servers with the newest NVIDIA cards, and the Institute for Computer Science and Control, they are planning to purchase 8 GPU servers with also NVIDIA cards, and the two entity to not just make infrastructure as a service, but platform as a service, so to build many orchestrated services. For example, to easily start in Kubernetes cluster, Jupyter Hub, and many other things. We hope that this happens at July. Thanks for your attention.
Thank you very much.